All right. Hi, Emilia and Marie. No, both of us are in the WhatsApp group for the Caribbean studies. Any you managed to do any section yet? I think D was left for you, Emilio. Because I forgot to put everything together and I forgot over everybody's section to ensure so that the answer actually is the correct answer, what we should be supposed to be submitting in our presentation for August 5. Hello? Hi. Emilio, Marie? Hello, Marie, Emilio?
Tashana, I am unable to answer you. I am where Pure Nice is.
Okay. All right. All right, before Sir come in, I wanted to show you something. So this is what my Caribbean study thing look like. What I did for unit 1, I had to, because of how she laid it out on Canvas, I said it was kind of confusing, having to go up and having to go down. Everything for 1, I outlined and save it to unit 1. That's how I was able to study. For unit 2, everything she put there, I had to number them based on the schedule that she'd given us. I keep calling it schedule, the coursework outline. So these, the first section from 1 to 2, how it's listed in the, I should bring it up and show you in contrast so you can see what I'm talking about.
Yes, I needed to do that so that I can see you. And I wouldn't mind if you, although you want to do all of the work, but I wouldn't mind if you could be so kind to share, because trust me, you see, when I was trying to go through, I was confused, and that is why I didn't get to read through this thing properly.
All right, so this is what I was talking about in terms of content. That's not what I looked at. All right, that's what I looked at first. In terms of content, she wanted us to be able to locate all of these on the map. So I go over the map and I tried to identify as much as I could. So I went over unit 1. Now in unit 2, this is what was listed. So as I said to you, if you can look at this, I'm gonna split the screen if you can see it. Sorry, let me move this back. I should make this a little bit bigger. Go 75. Yeah. Right. So under unit 2, everything that she posted on Canvas, and by everything, bring this over and show you what I talk about. Under unit 2, you can see them and compare them, the Tanos and the Canalingus. They still can't pronounce them, I'm not gonna try. When I talk about the indigenous people, I put that under 1. Under 2, the colloquial experience, they put that under 2. Then you have A, B, C, all of that. So what she did, sit here, under 2, you'd find A2, where we talk about Europeans. So we stick with the 2B. We talk about slavery. Each of them had to number them just so I could study it, showing all of them. And this came under 3. That is the same unit 2, you see 3 independence. It started with apprenticeship, independence in the Caribbean, and the road to independence. These 3 came under that heading. So because of how she set it out on Canvas, it was very confusing at first. And then I say, you know what, let me compare it with the outline, the course outline for unit 2, and see what is really needed. And that's how I was able to do it. If not, I don't know how to manage, I swear. So
it me used to the course outline.
Genius.
Yeah, I had to do
when
that.
It was something on Canvas way so confusing.
Yeah. So until I put it into some semblance of order, everything was just here and there. I made sure when I save it, on the right, you're looking at my thumb drive. The assignments to be graded, I have that separate. They have unit 1, unit 2, unit 3, and then this course line, the syllabus on the left, is what I had to compare. If not, I don't only manage for the exam that sir. Let's stop sure because I don't know if sir will log in it because sir going in class. But all I'm saying is if I didn't do that, I don't know how would I manage. Believe you me. Oh,
I did the exam and I don't read nothing at all. Trust me, because the first something I read, I'm confused. I couldn't get to do.
The struggle real, Marie. But all you do is ensure so when it come on to Saturday exam, which is small business management, you try to read. As a matter of fact, most of the stuff are on Moodle. They're in video format. So you have to go make time to go sit down and watch the video them. Yeah?
Okay, sir. And thanks for reminding me.
Yeah, man, no problem.
Tashana, she not send me our slide.
Huh?
She not send the slide.
Which slide?
Small business manager is not send no slide.
All right.
Yes, she sends slides.
She
Oh,
sent some stuff to our
last
1J
email.
email address.
Okay.
Yeah, the only one we can't find is
But
unit
most of
3.
the stuff we need are on Moodle. Here,
Unit 3 is
most of the stuff we
on
need.
Moodle, Tashana.
I'm not sure
And
if
we
it's
can't
labeled
find it.
as unit 3, but if you know the topic under the outline that you sent to us, then you'll know. But
Yeah,
in the back of my
I guess it's
mind,
sort on the
that's
mission
what I go through.
statement.
Because I started, yeah, I started going through Moodle, so I know say most of the stuff that are there are in video format. So I think they probably figure it would be easier for us that way. But you're not to go over it. Trust me, it's a lot of information. It's a lot.
Hey guys, good afternoon. Good evening, sorry.
Good evening, Mr. Sean.
Good evening, sir. How are you? Sir Sean?
Hello, anybody, somebody?
Are you hearing us,
I know
sir?
the problem. Don't say anything else. Crazy Mr. Shan. Hold on. All right. Let me see if I can. Good evening, guys.
Sir, I can hardly hear you.
Right. No, I wasn't hearing it because I was in a meeting just now with some students from a program, and so this is I'm just coming over to you. So I was using another device, and I thought the headset was plugged into this device that I'm using for the class. So I apologize for coming in late. So let me say it now. Good evening, guys.
Good evening, sir.
Good evening, sir.
Only do.
Sir, I've been very bad, and I could have been better, but that's just life, sir.
Yeah, but how many of you did any business captures since last Thursday?
I did some of the practice ones on on EducaSoft. I don't try the homework or the test yet, sir, because I haven't been through how they do it on EducaSoft. I know how you showed us the concept before, and I've been practicing that in my book. But the ones that are on EducaSoft, I've attempted the practice. But I'm going to before it's Saturday, sir. I have to do the homework and do the actual test. I just don't want to get a failing grade on it. That is my apprehension, sir.
Okay.
Sir, my last grade it intimidated me, so I'm kind of afraid to go back on.
Okay, Miss Marlene.
That's only one person in our class, sir.
You don't want me intimidate you, or you say go grow.
Oh Jesus, no.
Sir, I'm not afraid of you, Mr. Sean, but I'm afraid for fail.
All right.
All right.
Sir, what go on? I'm gonna beg you boss a thing for me. I mean, you know, boss it. What go on?
Eventually, it will eventually.
All right.
Yeah. All right. So I'm seeing some movements, and I'm very proud of you. Congratulations. You know, I'm seeing movements by others. It's just that Christopher is way out there. As I see one student two students who were missing from my class last time. I really hope that the meeting method that you had.
Sir, Sir Sean.
Yes, please.
I can hardly hear you. I promise you, I'm not trying to be difficult. I just really can hardly hear you.
Are you hearing me better now?
No, sir.
I don't know what else to do because I'm using you guys. All right, hold on.
It's roughly the same.
Is it any better?
Little bit. Let me draw this close because I'm thinking maybe it's my machine, but I booked mine to the volume 100 buck.
Yeah, man, my one too.
Oh Jesus! I'm gonna put in the earphone, sir. That's the last resort.
Oh, that's the problem.
Sorry?
That's the problem. No, man, that's the problem. Put in the ear set.
All right.
Yeah, man, that's the problem. All right. Jesus, I need to do that thing for that student as I see that student coming. Tajay, can you unmute for me, please?
Yes, sir.
Why don't you answer me when I speak to my class, sir?
Sir, last week, you have to rephrase.
So you did hear me talk to you?
Yeah, but I can't unmute.
So you know, say something in the chat then, boss. Say you make me vex in my class, and I'm
No,
come out of my
sir,
class.
laptop is self-freeze. Sir, I couldn't type it. Laptop is freeze.
You know WhatsApp. You know the WhatsApp group.
Yeah, I could have done this, but
yeah, man, do that, man. Do that. You did text me last week. I don't lie to you.
Somebody, man,
All right, let me get up now again. Do you pop up? All right,
yeah,
nice. All right, cool. Easy. You can mute now. All right.
Sir, what did I miss?
Ophelia, yes, what paper are you talking about? I am missing something. What paper are you talking about, Ophelia?
So you sent it already? The one that was working on last week.
Jesus, Lord. I have so many things on my head.
So maybe it's one that you did send up before then.
Yeah, because did I update? I don't know. Forgive me.
So I think you was updating. You was updating it. So you were supposed to send us the updated.
Oh, and I never sent it.
No, you never sent anything.
Well, guess what? I profusely apologize because when I responded to you and I asked, I'm saying to myself, what paper is Ophelia talking about? All right, no problem. I will. Yes, please.
The same paper I was about to ask because I went back to my email to see if I'd sent it to myself. I went back to the chat to see if it was the last one. I know what we did in class the last time with everything that we worked out and the chain rule and all those rules. We never got that document. No, we never got it.
Okay, all right. I apologize for that. I have it. So sorry. I have it here. All right, Jesus. No, I have too many things open up. Are you speaking about this one that we did the quotient rule and we did the example
yes,
right
sir,
here?
I don't have that paper.
Okay, all right. I apologize. I thought I sent it. I honestly thought I sent it. And this is the end of this document, because I opened the document just now because I look to see some do know questions that I have here, and I have one here as a warm-up that I already did. And then I was supposed to go through some exponential functions
and logarithms
and the logarithmic functions, the square root function. I need to do that and then I must move into stationary points tonight. There is no way unless God comes tonight, but I must move to stationary points. I have to. If I don't do that, guys, I'm going to be in serious problems. This is week 6. And I start getting worried. You know why? Because I'm saying the students are learning, Lord, but it is taking too much energy, right, in order for them to get the fulsome understanding. What I'm saying to you is that I'm not able to move faster. I know you guys are getting it, Not everybody at the same pace, but I know you guys are getting it. But my general concern is that I'm spending too much time. I should have been farther than where I'm at just now. And that's where I am, and that's where I am, and that's where I am concerned. Hold on, let me just say, hold on. All right, guys, sorry about that. Yes, dearest.
Did you saw Shauna K email?
I did.
You responded?
Maybe not. But
So
it's not for me to respond.
yes,
Is no?
it's to
She just
respond that you have seen it because you're the type of person to not see something, not see
you
an
know come
email, not see a WhatsApp.
you know come to me the type of person maybe when you know come to my class because you study for your exam,
Sir?
right? No. Me have you up. It's just like when me have up to me have you up big time. So you know come to me the type of person that I am. Have a wonderful rest of the day. Cause you know you're silent. You miss my class to go to somebody else's work. Irresponsible. That's all I'm going to say to you. Irresponsible, JD. I'm very disappointed. Let us move right along. Um, so let us go with the document. So I'm going to send you the document. I'm going to send you the document. I just didn't
Appreciate
send.
it, sir.
Yeah, I'm forgive me, Lord of mercy. You need me to send it
Sir,
all.
I want to ask you a quick little question.
Yes, sir.
So may I look for some things I may say more do econ as a major, right? I want it one
Nice.
more.
Okay, man. Once you do econ,
Mm-hmm.
below differentiation and integration because you have to go to the elasticity function and it's a very good field though. I mean, as an economist, your math will have to be there, and it will be a very good area for you. Yeah, man.
So like you just frighten me out of that
No,
option.
man. No. Trust me. As an economist, you can. It takes you anywhere to work. You can go into the bank to work. You can go and teach. You can go at any financial institution. You can go airport. There is. You can go to a hospital to become the CFO or something because you I mean you will have the stuff. Yeah, man. You can really have a very good option. Um, the thing about it is, I would say to you, um, well, you know that we offer the masters now at Excelsior. I would say complete the bachelor's degree and then do wherever you want to go and do the masters in econ. You would have been exposed to econ just at the very basic level, but when you're going to be doing the masters now in econ, what will happen is that you're going to be required to do some bridging courses. Say, for example, if you're doing, if you did, say, tourism, the associate degree in tourism, and then you want to do the bachelor's in business administration as opposed to tourism, there are some basic courses at the associate degree level in business that you must do. So they may say to you that you have to do spend the first year just to do whatever it is. Me don't know them courses. You just do some courses, and then at the end of the first year, then you can move over now fully into year 3 of the bachelor's program, right? So wherever you go, there are going to be some bridging econ courses that you have to do since your major wasn't econ for the bachelor's, but business administration. But you'll have that background, so you can go and do it. But I would encourage you to do it though. It's very nice. It would be very nice. To be very nice. And I like the way of thinking. As you guys are wrapping up your associate degree, I would really want to hear you guys, futuristically thinking now that I'm going to move on to the bachelor's, but I also need to move on to another degree. It makes me a very proud, teacher to know that boy, you guys are not just standing with the associate or the bachelor's. Very good. Consider it, man. Read up some more. Look up at on different institutions locally and internationally, and see which one offers the best option for you. All right. So we are going to be doing. All right. Let me give you this warm up. Let me give you this warm up. Let me give it that warm up. I'm going to give you 5 minutes to do that warm up exercise for me, and I'm going to ask you all to try as best as possible to do that warm up. Follow the rules that I would have given. And unfortunately, I didn't even send the paper, so it is that you can go look back at it, but never mind. Look back at what it is that we did and see and see if we can just work through that question for me. Let me ask you one hint. Well, not hint. I'm going to ask you, what rule would you use to find the differential of this function?
The power rule, sir.
Okay, any other suggestion? Any other suggestion?
I mean, sir, the chain rule can be used, you know, but it's going to be a little bit longer.
Any other suggestion?
Could that be first principles too?
No, man. The only way we can use first principles code is unless them tell me. Don't get into the habit of it. And first principles studies is going to be very long. They wouldn't give you a question like this for first principles. This is very long. You're bound to get it incorrect. Trust me.
I go with Tashana then. Power rule.
Power rule. Any other suggestion? All right, let me call upon people then, since you're not talking to me. Jenna, what say you? What rule do we use to do this one?
Sorry, I just went to give the dog something to eat. Can you repeat the question?
And I'm just saying to you, I'm giving you a warm-up exercise.
Why am I not here? Okay.
You hearing now?
Yes.
Right. So I'm giving you a warm-up exercise. Y is equal to 8x to the 5th times 4x squared minus 2 raised to the 5th power. And I want you to find dy by dx. I'm asking what method would you use to do this question? Talk to me. What method do I use? Ricky, tell me what method I use. Help her out.
Sir, I would use a power rule on this one.
Use a power rule on this one. Okay. All right. Romain, what rule do you use?
Yes, I'll go with the power rule as well.
Power rule as well. Okay. Marlene, what would you use?
Repeat, sir.
What rule would you use?
The power rule, sir.
Power rule. Okay. Christopher, what rule are you using right here?
I hope so, but I know you that tell me, but all right, power to them.
You say power too?
Yeah.
Okay. Emilio, what rule are you using right here?
I forgot to say me first tell us me that go with
Yeah, you did say it. Yeah, you did say it. Marie, come, turn off the fan and come talk to teacher. What rule are you gonna use, Marie?
All right, sir. Sir, I remember you showed us 2 ways. I think I don't remember them quite well, but the shorter one, sir. The one that the shortest one, sir. I don't remember if it's the power rule. It's the shortest one, sir. But the shortest one. That's the one I think you should.
Okay, all right, no problem. Joan, what say you? What rule do you what do you use for this one?
The power rule, sir.
Okay, all right. Ophelia, what say you? Ophelia, what say you?
Sir, 1 second. Yes, sir. Which rule?
What rule do you use? Yeah.
I was looking at the chain rule. I'm not sure.
You're looking at the chain rule. All right, no problem. Ayana, come talk to teacher. What rule would you use to do this question?
Sir, the chain rule.
I'm change to the chain rule.
You change to the chain rule.
Yeah.
Okay, all right, no problem. Change is allowed. Satania, what rule would you use? Van, you're next, so think about it. Satania, all right, Van, answer in the meantime, Van. Vanessa, what rule would you use?
I would go with the chain rule.
You go with the chain rule. Okay.
Yeah.
Can I tell you all a secret?
Sir, oh, that sounds so.
Sure, sir. Go ahead, sir.
So like the two are wrong, sir. My way I'm going with him.
Not the two, Uno. The whole of you.
Jesus Christ.
Not the two of you. Look back
So
at the function.
you make it look like when I learn now. Jesus, I'm
No,
crying.
no. Look at it and tell me. No, you see, and I don't want to comment just yet. I'm going to give you one other opportunity to look at it, and anybody, just any one person, just one.
Power rule.
That's what I've been hearing.
Sir, with the dy over dx, you see, because I didn't get this paper to look over it, sir. The one that's fresh in my mind is the power rule.
Nobody rub the salt in the wound. Jesus, he just rub the salt in the wound. Yeah,
Remember that. I would have one name again, Jesus.
I'm sorry, sir.
It's your product rule.
Thank you very much.
See, it looks familiar. It looks familiar, sir, but I'm saying
it is called the product rule. No, but Tashana.
Yes, sir.
What most of you say, is only half right, because in this, remember, 8x to the 5th is being multiplied by 4x squared minus 2 raised to the 5th power. So you have one term. Lord have mercy. How do I do this? Hold on, guys. I am doing this document for you to get you to a point where it is that you can understand first. So you know that when I stop like this is to get you in a better position. All right. So I have my first term, which is the 8x to the 5th, being multiplied by the second term, which is the 4x squared minus 2 raised to the 5th power. So this is the product rule. But guess what? Within this product rule, I agree with all of you, there is the power rule involved in the product rule. And see the power rule right here, so 4x squared minus 2 to the 5th. Remember, sir say, you see, once the number here, so greater than 2, don't even think to do no multiplication. And to do the chain rule can use, but let me show you the chain rule I'm going to use now. You have to go expand 4x squared minus 2 to the 5th power. Nobody got time for this. Unless you're going to say, geez, Pascal's triangle, 1, 5, 10, 10, 5, 1. Nobody wants to go back to pre-calculus. Or you're going to use a combination notation to do this expansion. And trust me, when you do that expansion with a combination notation or Pascal's, you are going to be likely to make a mistake and you're going to be likely to get the question wrong. And after you do the expansion here, then you have to go multiply this by everything inside of the back. Way too much work. So it's a product rule, but in this product rule, they have the quotient. Let me just show you something. I don't have any like that. Yes, number 13. Look at what I did for number 13. What rule do I use for number 13? Quick and fast.
Chain.
Very good. And how you know it's a chain rule?
That over X business there.
No. The over X business is quotient. And that's why I ask you how you know it's chain. Because I put things in there to kind of confuse people. It is chain because the terms are separated by plus signs and minus signs. So I have 3 terms here. The first term is 4x cubed.
4x squared.
4x cubed. Sorry. The second term is 2 over x.
2 over x.
Which is a quotient, but I don't business with that. And then the third term is 3x times x plus 1, which is a product, but I don't care about that. It is still the chain rule, right? So it is a chain rule, but in working it out in the chain rule, there are several things to do, right? So that's why you see me have part 1 and part 2 and part 3, because there are several things to do, but this is still a chain. Why me? Oh, you know, sir, it means that I have to go do this piece first.
Yeah, piece by piece.
Piece by piece, and that's why it's called a chain rule. But even though I'm doing it piece by piece, I still can have the product in there. I still can have the quotient in there, but it is really a chain rule. Sir, what are you saying? Exactly here. So this is a product rule because I have a first term being multiplied by a second term. But this second term now, in order to differentiate the second term, I have to use the power rule. So the point I'm trying to make, while I'm getting very excited, is that you can't just decide that you are going to learn only the chain rule or the product rule or the quotient rule. you have to know all the rules because you don't know how the question is going to come, and you have to go use. I can give you a question where you use all 3 rules. Matter of fact, see it here. This question. No, but it's right here. But and remember this question. No man, look here. The same question. Yeah. All 3. The whole of this. The whole of this is the chain. The whole of this question here is the chain rule. Here so alone is the quotient rule. Here so alone is the product rule, right? And even put a square right up here, so or something else, it would have been the power rule. As a matter of fact, the power rule is still involved in here. The power rule is still involved in here.
X of a power of 1.
Very good. Excellent. So I'm saying to you, I can give you a question where it contains all different all types. All right. Now that you know, start on this one, please. I'll come back and do it. I'm going to separate after you. Just start and do it for me, please. Start, guys. Hear me out before I step away. I need to go and refresh myself. But hear what is happening, students. If you're not fully understanding, I don't want you to fold your arms and say, I'm going to wait until sir comes. Put pen to paper and see how far you can get to, so that at least when I'm doing the question, you can see where it is that you would have gone wrong or where you needed to pick up from. So please, I don't want anybody to not do anything. Start for me, please.
Sir, before
Yes,
going
please.
on my internet at cheap out, I know what go on tonight, so if you don't see me in and out, I'm internet.
He tried to tell the internet to stable himself. Never mind, Papa. All right, never mind. All right, cool. Are you all finished? Anybody finished?
Sir, can I be honest for a second?
Sure.
I had to step away when you were going back up, you scroll up again. I had to step away. So when I came back, everybody was quiet. I only remember vaguely the product, sorry, the power rule and the chain rule. The product rule now, I'm going to go on YouTube to go find it because one, I still, it's a mystery to me.
No, you don't have to go. This is never mind. It's all right. You have two devices on. You need to mute one or deactivate one or disable. All right, let's go. I don't want to go on YouTube for that because I don't know how YouTube is going to present it. So that's what I'm saying. I prefer doing it for you. All right, let me just pause and go through the question. All right, saw that message. All right, I'm just going to encourage us to try and catch on to these things. I really don't want to move on when I know that you guys don't fully understand. But I really can't spend quite a bit of time on this. So let's go. The product rule says the first times the differential of the second plus the second times the differential of the first. Watch me. The first is the first here times the differentiation of the second. Now, in differentiating the second, we have to use a power rule. What's the power rule again, sir? This 5 comes in front of this, see here, so. Then I'm going to write back all of this and reduce this by 1, see right here, so. But now I have to differentiate what is on the inside of this here. And the differential of 4x squared is going to be 8x. The differential of negative 2 is 0. So this is it. The first, I write him at the first as it is, the first times the differentiation of the second. The differential of the second is what is in pink, using the power rule. Is in pink, what's in the power rule? All right, so it's the first times the differentiation of the second.
What is in what? I did not hear that. What is in
what? What is in pink is a power rule.
I mean,
this here is a power rule. Whatever you have in pink here is a power rule. So let me go again. So the question is here, y is equal to 8x to the 5th times 4x squared minus 2 raised to the 5th power. It's the first 8x to the 5th. See here, the first 8x to the 5th times the differentiation of the second. Now when I differentiate the second, I have to use a power rule. So this is going to be 5, going to come in front of the 4x squared minus 2, and then I'm going to reduce it by 1. See here, the 5 in front of it, then I write this back and I reduce it by 1. And then why it's called a power rule? Because I now have to differentiate what is on the inside of the parentheses. The differential of negative 2 is 0. The differential of 4x squared is going to be 8x. Right?
sure, reduce it by what?
By 1. You remember when you're differentiating, you subtract 1 from the power?
Yes, sir. Just see what you're talking.
All right. Let me write it though as I recall. Oh Lord, where it is? So follow. All right. So y is equal to x to the n, then dy by dx is going to be equal to nx to the minus 1. So we always subtract from the power. Always, every single time. All right?
Right there.
All right, so this is the first times the differentiation of the second, then plus the second now, plus the second. See, I write down what my second is, so nobody can miss that. Plus the second. So plus the second. See the second here? Plus the second. Now I'm differentiating the first. When I differentiate the first, the differential of 8x to the 5th is going to be 8 times 5 is 40, 40x to the 4th. See here? 40x to the 4th. My differentiation ends right here in this line. What I'm going to do now is to fix up. And in fixing up, I'm going to see what is common. Well, 8 times 5 is 40. Yes, please.
Why did you change the power of 8x?
By who?
Why you change the power for 8x? But I know it's 40x, but you put 4 to 4.
See it yourself?
So yes, oh, so you continue. Okay.
Not continue. When you differentiate, you always
You
reduce the power
continue
by 1.
minus in the power of taking off one of each power.
Yes, because you're differentiating. Whenever you're differentiating, you always subtract 1 from the power. Whenever you differentiate, you always subtract 1 from the power. That's what differentiation is. So once you're differentiating, you have to. Can you move from it, please? You have to subtract 1 from the power. Is that any clearer?
Yes, sir.
Can I put some salt in the wound?
Go ahead, sir.
This is what we did in last class. So for those of you who missed last class, you're going to have
I
a difficulty.
didn't know you were going to say that.
I know, and I know that's why I asked for the salt in the wound. So I think I would have just made my point very clear. Thank you. All right, so let's go again. Y is equal to x to the n. When I'm differentiating, the rule for differentiation is I'm going to take the number up here, so put it in front of the something right here, so as a coefficient, and then I'm going to subtract 1 from the power every single time. See that, so dy by dx is going to be equal to n. The n here go in front of the something here, right here, so. And then I will always subtract 1 from the power. And that's why I have the n minus 1. All right. So with that said, let us move into fixing up the question. And fixing up the question now involves me looking to see what is common. And even before I do that, 8 times 5 is 40, and 40 times 8 is 320, and x to the 5th times this x will give me x to the 6th. So when I multiply everything right here, so it gives me everything right here, so.
Right, sir, 1 second. I get the 320x, but the 6, that is kind of confusing because initially we had the 5 there. We know that we will bring it across, it became the 4. That is where the power rule is right there beside the 2 open bracket. You see the 4. So my question is 320x, that 6, how we got that 6 right there? To the 6th power? Right, 8 times 5 is 40, 40 times 8 gives you 320. I got that, sir, but I don't understand.
Yeah, 5x, 5 to the x to the 5, and then you have 8x. So that 1x there beside the 8, Tashana, it make the 6.
Oh.
But Marie.
That just, I mean, you know the donkey, the donkey saying, or the lollipop saying sucker, yeah.
Very good, Marie. Excellent, Marie. Woo! You see Natasha? You see Natasha?
Yes, I see it now, sir. Thanks. Thanks, Marie.
Very good. Very good. And then now, this 40x to the 4 is going to be in front here, this 40x to the 4. And then, so all I'm doing is just rearranging right here. So having rearranged to get this, I'm going to see what is common. And what is common now, of course, we say that the 4x squared minus 2 to the 4th, 4x squared minus 2 to the 5th, we always take out the lower of the 2, so that means it's 4x squared minus 2 to the 4th that we're taking out, the one here. But is there anything else that is common?
What was that rule, sir? You always take out the which one, sir?
The one that is lower.
Okay, thanks, sir.
So you're always factorizing the lower of the 2. So watch me. This is x to the 6th and x to the 4th. We can't take out x to the 6th because we don't have enough of it over here. So x to the 4th we have to take out. So that's another x to the 4th. You always take out the lower of the 2. All right? And then no, I can't factor out 320 because I don't have as much as 320 out there. So, but I can take out the 40 because the 40 can, all of the 40 can come because the 40 is also contained here. So what I can factor out is going to be 40x to the 4th times 4x squared minus 2 raised to the 4th power. So I can factor out all of this. This is my complete factorization. Then the question is going to be now, what is left? The question is going to be what is left. The x to the 4x squared minus 2 to the 4th is here. And I have all of it right here, so I don't want any more right there. But I have 40x to the 4th, but I want 320x to the 6th. So it means then that I'm going to have 8x to the 2nd power. Why, sir? Because 8x to the 2nd power times 40x to the 4th power will give me 320x to the 6th power. This is already the same thing as this. And then, when I reach this portion now, I recognize that this 40x to the 4th is already outside here, so. And I have beside it the 4x squared minus 2 to the 4th, but I have 4x squared minus 2 to the 5th. That means we need one more inside here, so. So that's why I write the 4x squared minus 2. I could write to the 1st power, but I don't have to write it. All right? And then, I'm just going to simplify. Simplify my square brackets. Let me just cut. End. Right?
Oh, jeez.
What?
I did step away and miss all of them explanation you're working out there. Lord mercy.
It's all right. Don't worry about it. So I'm simplifying the square brackets. So when I simplify the square brackets now, you notice all of this here is the same thing as everything right here. So I'm just simplifying this. So this is, I put this one in green to show you that I'm multiplying 1 by everything here. So this is 1 times 4x squared is 4x squared right? And then 1 times -2 is -2. And then 8x squared plus 4x squared is 12x squared minus 2. So that now becomes my final answer. That now becomes my final answer. All right, so let me just go through it one more time. Let me do this so that I can do that. So that's a question. We're using a product rule. Using a product rule. It's the first times the differential of the second plus the second times the differential of the first. The rule says y is equal to x to the n. dy by dx is going to be equal to, remember, we take the n and put it in front of the x, like here so, and then we always reduce it by 1. Remember that?
Yeah.
All right, good. So it's the first times the differentiation of the second plus the second times the differentiation of the first. So the first up here, so that's the first. I'll write it back. Times the differentiation of the second. Now, the differentiation of the second is going to be the power rule. And remember what the power rule says. Power rule says that I'm going to take this 5, multiply it in front of you, so reduce it by 1, and then multiply by the differential of the inside of the brackets. Very good. I heard that code. So this is going to be 5 in front of that. See here, 5 in front of that. You notice this was 5 up here, but it's now 4 because the rule says I'm supposed to reduce it by 1. And then now I'm going to differentiate what is on the inside of the parentheses. I'm differentiating what's on the inside of the parentheses. And when I do differentiate here, when I differentiate -2, I'm going to get 0. Why do I get 0 when I differentiate -2 again?
Because anything times the power of 0 gives 0. Or something to that. It's a constant. Sorry, yeah, sorry. Yeah. May I always say my way first, but yeah, it's a constant. Sorry about that.
Yeah, very good. I heard you, Christopher. Very good. So it's the differential of a constant. So the differential of a constant is always equal to 0. All right. So watch me now. So because this is equal to 0, I'm now going to differentiate 4x squared. The differential of 4x squared is going to be 2 times 4 is 8, and we have 8x. See the 8x right here, so? But I have completed the power rule using this. See here? That's the power rule. Then now I reach a plus sign. Plus the second, see the second here? I'm writing on the second, plus the second, times the differentiation of the first. You differentiate the first. Differentiating the first is going to be 5 times 8 is 40. 40x to the 4th. See here? 40x to the 4th. I can rearrange in this stuff a little. Because when you say 8 times 5 is 40 times 8 is 320. And x to the 5th times another x to the 1st out here, so is going to give me x to the 6th.
Yeah, hold on, come again, Panda one.
Come in. Based on the question that was asked, let me just put it like that. 8x to the 5th times 5 is 40x to the 5th. And 40x to the 5th times 8x to the 1st is going to be 320x to the 6th. When you're multiplying and the bases are the same, from pre-calculus, you add the powers. The base here, x and x are the same, so you can add a power. 5 plus 1 is this 6.
Yeah, that remember. Oh, and you say, hold on.
8 times 5. 8 times 5 is 40, and 40 times 8 is 320.
Oh, yes, because I'm multiplying, yes.
Multiply. So all of these is a multiplication here. So we can't do nothing but multiply. So the plus sign here, the plus sign separates the operations. Remember, that says multiplication and division before addition and subtraction. Remember that story last week?
Yes,
so,
sir.
So I have to keep the sign by itself and then do the multiplication after. So this 40x to the 4th, I just put it in front here, 40x to the 4th, and then I write that. I'm giving you a note. To say that always factorize the lower of the two. So in looking at this, you have 4x squared minus 2 raised to the 4th power, and 4x squared minus 2 raised to the 5th power. Hold on there. Give me a minute here, guys. Sorry about this one. Go on, look at it in you can, please. All right. Any clear to anybody?
Oh, me see you get a plus 40x, you know. Where that come from? Okay, so in a after the rearranging work. Oh, that way. Okay. I remember say that did all this one. And put it in front. Oh, okay, I put it back in front. All right. Okay, all right, move on.
All right, so that's actually rearranging. All right, so note, always factorize the low of the two. What do I mean by that? Let's just start here. So I have a 4x squared minus 2 to the 4th, and I have a 4x squared minus 2 to the 5th. I'm taking out the lower of the two, and the lower of the two is going to be to the 4th power.
4.
So I talk about that now. Similarly, I have an x to the 6th, and I have an x to the 4th.
X to the 4.
I have to take out the x to the 4th because I have to take out the lower of the two. Similarly, I have 320 and I have 40. I have to take out the lower of the two. 40 is a factor of itself and 40 is a factor of 320. So I have to take out the 40. So all that I can factorize is the 40x to the 4th times 4x squared minus 2 to the 4th power. That alone can be factorized. Nothing else is common. And then now, I'm going to ask myself, what is left? Asking myself the question, what is left? Here my answer. What is going to be left, sir, is not 4x squared, 8x squared. When I multiply all of this to everything inside here, I'm supposed to get back everything up here. So 40x to the 4th times 8x squared. The x to the 4th times x squared will give me x to the 6th. And the 40 times 8 will give me 320. So I know that this piece times this piece gives me about this piece, which is being multiplied by this piece, which is a 40x squared minus 2. So when I multiply all of this by the 8x squared, I'll get back the 320x to the 6 times 4x squared minus 2 to the 4th. All right? My plus sign.
The 8x squared plus 1, 8x squared come from?
That's what I'm saying. It's going to be what is left from here.
After you can take out it, okay.
Right. So how many times can 40x to the 4th x times all of this go into this? Is going to be 8x squared times. All right? And then now I'm going to say, since I factor out this, I now need to see what is left in order to get this. But sir, hold on. This 40x to the 4th is the same as this 40x to the 4th right here. Is the same as this 40x to the 4th right here. And then I have 4x squared minus 2 to the 5th. But I have this 4x squared minus 2 to the 4th. That means I have one more to get. That's why I write this here so. That's why I write this right here so. All right? So when I multiply all of this by all of this here, I'll get this 40x to the 4th times the 4x squared minus 2 raised to the 5th power. All right? So now I'm going to be simplifying the square brackets. I'm going to be simplifying the square brackets. And when I do, I'm going to say 1 times 4x squared is 4x squared and 1 times negative 2 is negative 2. And then you still simplify the square brackets. X squared, 8x squared rather, plus 4x squared is going to be equal to 12x squared minus 2. And this now becomes my full answer. This is a long question. A question such as this in an exam can come anywhere between 5 and 10 marks. Anywhere between 5 and 10 marks. And please do expect one of these questions. Expect one of these questions.
Thanks for the heads up, sir. Just remember, please, to send this paper, sir.
Sir.
Yes, ma'am. Sir.
By any chance you could send us the recording?
Yes, ma'am.
Please.
Yeah, ma'am. Are there any questions regarding this? All right, so.
Sir,
Yes, dear.
I recall that when if the number outside the bracket is positive and the number inside of the bracket is negative, the one outside the bracket change the negative to a positive. Is that so in this case?
Which one are you talking about? Where are you talking? Right here?
Yeah.
And multiply this positive one. There's no negative sign on the bracket now. The only time the sign changes is when you have a negative sign outside here. This is a positive one, not a negative one. Had it been a negative one, this sign would have become a positive two. So I don't know if that, I don't think I understand your question. What's the question?
Never mind, sir.
Okay. All right. See, I put another question right here. That I want you to do for me. All right. So let me just reduce this. Let me just reduce this so that okay. Let me do it another way. Yeah, that's a much better way. All right, so question number 15 is what I want you to do for me. Oh, come on. Hold on, guys. Hold on. Oh, man. Oh, I thought I lost the information. I was just about to scream. All right. So the warm-up question here, you're seeing that as an example. Question number 15 is what I want you now to do for me as you're doing now. I am muting, but I'm right here. So if you have a question, please shout out to me. I'm just going to be muting. If you have a question, shout out. I'm right here listening.
Okay, we'll do, sir.
Sir, is this the same paper that you were supposed to send from last week? You're continuing on?
Yes, honey bunches. It's the exact paper that I should have sent last week. That's the same paper I'm continuing working with.
Okay.
So as soon as I could send it now, but because I'm still doing the stuff, and I say I just wrote question 15. I just want to finish doing the writing in the document and then send it out.
Okay.
Yeah, man, cool. As a matter of fact, what I'll do is, Ophelia, is because there's another document that I need to start. Before I start that other document, I'll send this off in a group while we're in class. Before I start the other document, because I must begin the stationary point today. Must. Cool.
Okay.
Make sure you guys are working in there. I don't want anybody to be sitting and not doing anything. Look at all the
Last
notes.
again.
Real loss.
The first part. Again. No, it's like me asleep. All right. I get back the part of the 8. And you say, all right. 8x to the 5th. And you multiply it by the 5 because you carry over the 5, put it in front of the bracket. And you get the 4x minus 2 same way. And you minus the 1. And you get 4. Right. But the part is a multiply by 8x to the 1. Where that come from again?
It times it by the differentiation of what is on the inside of the brackets.
Oh. If I now remember that rule, I know the first time is a different. Oh, sorry, sir. All right.
So you're multiplying by what's
yeah, that right. That's the next one.
All right.
I try again.
Cool. What about the rest of you? The rest of you feeling all right? Let me know.
Sir?
Yeah, man, I'm hearing it. Go ahead.
This atex right here, atex. Oh, you derive at
this one?
I understand the first part, right?
This one right here, sir?
Where you touching? I'm not seeing the thing.
You're not seeing it.
All right, so I know that you carried on right here, the atex plus 5. I know that is not. All right, let me talk in the question that we are doing right now. Then.
No, hold on,
right.
no. Marie.
I'm listening, yes, sir.
All right, tell me, honey bunches, look at the spotlight. Is this the 8x you're asking where I get it from?
Yes, sir.
All right, so you're the second person that asked now. So remember, the power rule says
Oh.
So much percentage class already? All of those percentage, you know. First principles. All right, so.
Oh my God, negative 30.
Power rule, where's the power rule? Power rule is right here. Let me just kind of. All right. So what the power rule says, y is equals to 2x plus 5 to the 5th power. Find dy by dx. I'm taking this 2 and I'm multiplying it in front of it. Here, sir. And then I write back this because I'm reducing this by 1. So this is 2 minus 1, which is this one up here. You see that? And then now this times 2 is OBGAINED is obtained from the differentiation DI from the differential of what is inside the parentheses. Let's see if we get that down. So this times 2 is obtained from the differential of what is inside the parentheses. See here, so 2x plus 5. When I differentiate 2x plus 5, remember the differential of a constant is equal to 0. So the differential of positive 5 is 0.
Okay.
But the differential of 2x is just 2. Okay. You see that?
Okay.
Right. So you have to differentiate what is on the inside. Let me fast track now down to here. That I want you to get. I want you to get this. See here now, Marie. Look, this 8x is obtained by the differential or from the differential of the inside. Here, 4x squared minus 2, the differential of minus 2 is equal to 0. But when I differentiate 4x squared, I'm going to get 8x. It's 8x to the first. Okay, remember this is 8x squared, and I'm reducing it by 1, so it's 8x to the first. And I wrote the first there again because somebody wasn't seeing that this x to the 5th times this x to the first is going to give me the x to the 6th.
Okay, sir.
All right. Should I start the question now, or should I do a few more minutes?
A few more minutes, sir.
All right.
So, sir, before yes. So in this case, the 5 would be the constant, right, sir?
Very good.
Okay.
And then I hear Christopher say something in the background a while ago. Oh, him get something. And I got to tell him say a while ago, but I was in response to him, And I said, no, but not, so nothing to you. Make him do him thing. Oh, Jesus. Sorry, I'm looking to see where we were. Right here. All right, continue. I'm right here listening on. Continue.
Sir.
Yes, yes.
For the 5 minus 2x cube, we can flip it around, or it doesn't really matter.
Good question. I would advise you not to flip it. And tell me why. Tell me why you think I don't want it to flip it, you know?
It might change up the answer.
Yeah, but in particular this one, what happened to this one? Christopher, what happened to, do you remember what you were saying earlier, Christopher? Or you get something, what did you say you get?
I remember me did I say, I tried it about 17 different times.
You were saying something about a negative, or you get negative 30.
Yeah.
Right. So so I'm just saying to you that you have to be careful, Yana, because you notice that the 2x cube is not just a positive 2x cube, it's a negative 2x cube. So if you switch it up, some students may want to put the 2x cube in front and the 5 behind it and not carry the negative sign. So the 2x cube is actually negative. So I would say don't switch it. All right, you know what?
No, sir, don't do it yet, Don't do it yet.
All right, now give 3 more minutes.
Yeah, man, may I try.
All right.
I see, more try for myself. If after you don't do it, if I not that me get, then me I say I never get that, this so on and so forth. Give me a few more minutes. Me still a try. All right, so this is you see. All right, sir, go on. Come here, I get lost again, a little bit again.
All right. Okay, no problem. It's always good when you can. when you
So I
can.
know say at least the part, as far as me reach, I wouldn't mind at this me dip on the right track. You know? Yeah.
Yeah, no problem.
Make us see how you do. Make us see how you deal it.
All right, no. So I'm just being, I don't want to say lazy, but I'm just copying and pasting as I go along. All right, so the first times the first is going to be 3x squared.
Right.
Times the differentiation of the second, which is going to be 4 times 5 minus 2x cubed.
Right. To the cube.
To the third power, very good. Times
6x.
No,
squared.
negative 6x squared.
Oh, a negative, see, that's
Yeah.
why.
The negative 6x squared, because remember, that's why I answered Yana the way I answered Yana. That's why I answered her the way I answered her. And then now plus the second
5x and 5 minus
5 minus 2x.
2x cubed to the cube. Yeah. Multiply by
2x to the fourth.
Yeah.
Multiply by what?
2x to the fourth. See, I'm last. That's all.
Which line it in, sir? Which line in? The first line said we.
Yeah, man. See the first line. Look at the first line. Tell me if your first line is the same thing as my first line.
No, I'm to the third.
No, man. Remember, say right at the second. You know, it's the first times the differentiation of the second. When you differentiate the second, you can get 4 times 5 minus 2x to the third raised to the third power times the differential of the inside, which is going to be negative 6x squared plus the second. So you have to write down the second, everything you're writing down for the second, which is 5 minus 2x to the
Oh, sir,
all right, sir. Off of my one, right?
No. I mean wrong. At the fourth power for two. Me wrong.
Yeah,
man. The power. I reduce the power, so that's my fault.
All right. Very good, Yana. I heard you. Ricky, were you saying something else, Papa? Or Toussaint? Toussaint, were you saying?
Yeah, man, I'm going around because me go put back the 3x square me put back, you know, right after you come out of the square right there, so.
Oh, no. But you see it now though, right?
Yeah, man.
What you get the 6 square? Negative
Okay,
6 square?
the 6x squared?
Yes, sir.
I differentiate what is on the inside of the parentheses. So the differential of 5, a constant is 0. And then, no, remember, the 2x
No, you have
cubed is
negative 2x squared.
Very good. It's a negative 2x cubed. It's a negative 2x cubed. So you're going to be 2 times 3, 6x squared, negative 6x squared. Because the negative sign is in front of the 2x cubed. So it's going to become a negative 6x squared.
That's why he me get this, you know, like a fool.
But Chris, I don't understand. You're saying something about then only get negative 30. Me want to know how you get negative 30 for true. Tell me why you get negative 30, Chris.
When I check too much things out, so go on.
Negative 30.
No, man. When I was explaining something to somebody, I heard him say, "They know how me get negative 30," and I wanted to respond to him, but I said no. Let him stay. All right, let's go.
So, sir, I thought that was 2 times 2 times 2. I thought that was 2x to the cube.
Which one?
Where you get the negative 6x squared right there. Right
Yeah,
there.
but there's a negative sign right here, don't it?
Yeah.
Yeah, man. So that negative sign governs the 2x cube.
Right.
You follow me?
Yeah.
You don't see it, you know, sir.
Watch me, man. Look. How many terms are in the parentheses? 2. All right. Name of the first term.
Constant.
No. What is it?
5.
Good. Name of the second.
5.
Positive 5. Name of the second term.
Negative 2x squared. 2x cubed.
Negative 2x cubed. So when I differentiate negative 2x cubed, I'm going to get negative 6x squared.
Because you carry the 3 in front of the 2, multiply it, and then you minus back the 1 from the 3.
Very good.
Yeah, man, I get it now.
All right, good.
I was doing it the other way around. I was kind of doing it to the power.
All right, let's go.
And when you get the 6x out, there's a times the 6x after everything. At 24x, me get that neither. Or you get by the 6x out this again.
I don't know. Oh, the differential of the first.
Oh. So 2 times 3 give you 6. Oh.
Yeah, the differential
minus
is
the 1, so a 6x. Jesus. See that? Sir, boy, man.
I take some time for smoking, you know, sir. I swear, that'll take some time for smoking, but you know.
All
right. Yeah, we get that part. All right.
What you're not seeing?
How you get the negative 6x squared?
I differentiate what is on the inside of the bracket. Can somebody explain to her for me, please?
Hold on, I'm gonna try, sir. Hold on. Take off the thing off of your screen.
I'll come in.
All right. No, man, don't move nothing. All right, ready, Nella? You hear me? Nella?
Yes.
All right. In the bracket itself, it's a 5 minus 2x cubed. We differentiate. Remember, say the constant are going to be 0. See? So the 5 gone. That's going to leave you with negative 2x cubed. If we differentiate negative 2x cubed, we are going to bring the power, which is the 3, and multiply in front of the 2x, negative 2x, sorry, and multiply it. So it's going to be 3 multiplied by negative 2x, which will give 3 times 2, negative 2, give negative 6. And in a differentiation, you have minus 1 from the power, so you have minus 1 from the cube, which will go left 2. So that will be negative 6x cubed.
Thank you.
All right. Yeah, may I try a thing, sir? I learned.
Nice. Yeah, very nice. One of the things that you always should remember is that whenever you get an opportunity to explain something to somebody, please do, because what it does for you is to concretize your own understanding. So I'm always very willing to explain and to help. All right. Tashana, are you there?
Oh, sorry.
I'm still here, sir.
All right. Me know it now. Go on for you, because you're very silent.
Very much so, sir.
Sir, oh, you know Tashana, so.
Sir, from the beginning, if I'm not sure of something, I'm not going to speak on
They
it.
just know
No, but never mind. Let me just finish this one and then.
You are going to know, sir. So when you get negative 72,
go ahead.
When you get negative 72x squared, positive 72x to the 4th, me get.
No, it's negative 72x.
No, the negative. I understand why I get positive. Because I remember saying I never have a positive 6x squared. But yeah.
Okay. Right.
I understand where you get the x to the 4th. That may I try to remember again. Oh, you add the. Oh, you add yes. So I'm right then. No, I'm right then. I'm good. I'm on the right track. I lie me at it.
All right.
I just never get negative. That's why. My own is positive.
Okay. All right. Good. No. Always factorize the lowest of the two. I'm going to take out that note here because I'm supposed to know this by now. No more.
No, man. Put it in back, sir. Left it.
Sure. All right.
Take out the things where I got guide with, man. Don't do that.
All right. All right. So what we're going to know, we're factorizing. So let me just copy this one. Copy. I'm going to paste it right here. Taking out what is common. What is common is going to be.
All right, sir. Can I just say something much like what I was doing before? From you put the question and I realized based on the power that it is being placed at, the last one, just like we did the first example, the one that we're supposed to do in class and warm up exercise, that one, sir. I noticed that the 8 and the 5 was 40. So at the end, the answer would have been 40x something to the square. And with this one, in the back of my mind, the answer to this would be 12x something. So it's just by looking at it, I came to that conclusion, but the working out in between, trying to figure out which goes where are it. To the right, where you have the actual 6x open bracket 5 minus 2x to the third power, and then that close bracket and to the fourth power. I think that is from the original question where we use that from the first principle. That is where that thing comes in. But I'm just looking at it and trying to understand exactly what is required to reach to that answer, sir.
All right. What is going to be required?
Sir, you don't have to send all the recordings. You see this particular one, sir?
No, I'm going to send them, man.
That one here, sir, please.
I'm going to send them, man. You see, let me tell you what is going to happen tonight. But I'm starting with something tonight, you know. We don't know how it will happen. If I forgot opening the head and make something percolate and season up, it will happen because I get through my other topic tonight. All right, let me bear on with me. Bear on with me. I may need to find another strategy. You know, say a 2-question with the sense. You know, let's go. All right, I know what I'm going to do to clear your mind. I'm going to finish this question and I'm going to clear your mind, reset it, and then come back. So I'm factorizing. Matter of fact, let me clear your mind. It don't make sense to go through because if you're not following what is happening here. All right.
Sir,
So,
my mind can't reset tonight. Like, just come out of our maths class before this, you know, said can't reset.
No, man. You're good, man. You're good. Let me ask you a question. And this is why I'm going to reset your headspace. Let me ask you a question. So there's a viral video going around, you see? For those of you who have seen it, where apparently this young man cussed out the PM and he was...
Yes, I saw it on the news a while ago, sir.
Right, he was sought, he was pursued and was forced to apologize. What are your views on it?
All right, sir. Sir, number one, freedom of speech. When they forced him to apologize, that was being infringed upon. And secondly, they said that that's not what they charge him for because he's a wanted person for some kind of break-in, something to that effect. But the point is that they forced him to publicly apologize, and that is an infringement on his inalienable right as a Jamaican. We're freedom of speech. He might not have been in the right based on the things that he has said, but the police should not have forced him to apologize.
But what is going on though, sir? Because you remember with the pastor and all of those things, why they can go on and find all of those people so quick, and then people were committing all these dangerous crimes and so on. They can't
find them. Because they don't want to find them. That is the point.
Okay, interesting.
That is the exact line I was going to say to you, sir.
Interesting.
You know why? Government thrives off crime. Without crime, there's no government.
Yeah. I didn't see the video though, you know. I don't see the video. I only saw the news on
I can marry. Don't worry about that part.
All right. Anybody else want to chime in? I'll spend 2 more minutes on this before
Sir, just 2 more minutes. As I said, just to be honest, sir, the first person that came up with that attitude would tell the prime minister saying now go in terms of freedom of speech. What they're sending a message, the police in Jamaica is sending a message that if you speak out against our head of government or anybody in a particular high position, you will be penalized for it. And to the long run, what they're saying is that the police did not charge him for that. They brought him in for a different reason. But if you brought him in for a different reason, why are you forcing him to apologize? The whole purpose of taking him is because you didn't want him to speak. Yeah.
Let me hear it, Marie.
The police behind it. I don't think it's the police behind it. I think
you know what my view is, sir. My view is what PG said. The law is not a shackle.
No, I want to tell you the matter about shackle forward. But anyhow, no, sorry, that was corny. All right, so
sir,
but Shuffleford, you're correct. Marie, you know what I thought you were gonna say when it came in the last part. You remember the first guy that was put into lockup?
Yes, sir.
The guy that said we're not going.
Yeah. So why was he locked up then? If this one is charged for being sought thereafter, why was the first one locked up?
It's the same thing.
Because him said not going.
You
So that
remember
means-
they tried to pull off something on the pastor to say the pastor have money and all of those stuff that never accounted for.
Put it this way, my only, I don't even want to talk about my viewpoints. Let me just tell you something. My only thing that I will say to you is the reason why you will not find this lecture in social media, because you see, the moment you put yourself out there, the higher the monkey climbs, the more the monkey is exposed. And in no way, shape, or form am I calling the Prime Minister monkey, right? Let alone this video, this recording goes out and I'm forced to apologize. It's just a Jamaican vernacular that says the higher the monkey climbs is the more the monkey is exposed. So for example, if I am in social media racking up all these views and likes and following, and I start talking, people will start saying, no man, the boy there, him a the thief from down a town, you know, I'm going to talk about all my teacher now. Or the boy there, no man, the boy there, it can't, and you know, and when people don't know anything about you, they fabricate and then know how the Jamaican populace is.
Sir, the big word, they make up things.
They make up things. Because what I'm going to say is that, yeah man, this is what normally happen, support and so on, and
when not go so.
And when not go so, and then no, people in the mainstream are go on say, blow wow, say, I true, because one day me left a pen on the desk, and 2 weeks later, me see Mr. Shannon at the register with it. He my teeth true, and then no, I'm telling you. So for me, this is why you will never ever in this life find me on social media. I've never owned a social media account, and I will not own a social media account. You understand?
But that make 2 hours, sir.
Yeah, that's what you do is up on WhatsApp.
And that's what I'm doing this up on WhatsApp. And I'm going to tell you what is happening though. When you're a leader, expect people to say things about you, and you can't muzzle them. It is against the law to try for Tashana can't be out there making decisions that will affect me, and I can't speak about it. Mark you, I'm not saying that the ways in which these persons speak and pronouncing death upon somebody, and it questions the person to say, well, are you really a Christian if you can say this is what may happen, and to go explicit something to go to your mother and so forth, and talking about the Prime Minister's sexual orientation and them. So I personally would not speak like that. That's not my jargon. That's not how I speak. But the truth of the matter is, when you go in some sectors, every other word that comes out some others' mouths is a bad word, because this is just how they are cultured, right? And for me,
sir, I heard what you're saying. That applies to a democratic society such as Jamaica, but in a communist,
Jamaica, we are not a communist like Cuba.
They want to bring it to that level. That's what they're going to do to most people.
In a communist country, then what it is that you have to swallow your thoughts. You can't say anything. But in a country like Jamaica,
it's like them know.
And I'm going to say to you, until the right, funny enough, there's this guy Altitude that I saw something, and I saw him apologizing. I was like, something is happening in social media why he is apologizing. And then by the time I look again, I'm seeing what is happening. But the truth of the matter is, until the right person is interfered with in terms of being brought to the books, and that person decides to get a lawyer to challenge the decision, before all of this foolishness where people can't speak their minds will stop. And I'm not saying that the way in which they speak, respect is due, and we have to respect the office of the Prime Minister. That's just my personal view. So whatever I think of him, I should respect.
Truth of the matter is, sir, he's a really a little waste man, but he's not doing no error. The truth.
All right. To be honest, like I
Simply
said,
put.
the muzzle effect that they're bringing across from the pastor to the guy that say him not going and him have gone them grandmother bed and him still come for him. This gentleman that spoke, yes, he didn't speak in an appropriate manner or respectfully, because he says most honorable prime minister, so you shouldn't really be belittling your leader. But the point is, we're not a communist country. We are a democratic society. And once our rights, our inalienable rights are being infringed upon to tell us that we're not allowed to say this, or we must retract that, he wasn't doing anything like libel. He wasn't defaming the man name. There's no, the man, we did defamatory stuff. I'm just saying, the point is, they're not supposed to muzzle nobody, just like what Sir just said. We are a democratic society.
Cool. Back to your match now, sir. Right, there, sir, right?
Yeah, me do this already, man. I was just waiting for her to finish off. All right. All right. So see right here. So all right. So let me go now. So I wanted to clear your headspace. So now that I've cleared the headspace, I'm going to go back to the question.
Sorry, the line below rearranging, right? To the extreme right. That 4 should not be reduced to 3.
No. Let me go back again, Chris. I'm going to tell you why. When I come back here, just remind me. I'm going to tell you why. So this is a given question. It is the first, which is this. Times the differentiation of the second. So I'm differentiating the second. When I differentiate the second, I'm going to get 4 in front of here, so see right here, so. Then I'm going to write a 5 minus 2x to the cube, and I'm reducing this by 1, so it becomes cube. So we have a cube inside and then a cube outside. And then now I have to differentiate what is on the inside of the parentheses. Differentiating what is on the inside of the parentheses, the differential of a constant 5 is 0. The differential of negative 2x cubed is going to give me negative 6x squared, which is this. Then plus the second, see the second here, so again, plus the second right here, Chris, which is the same point that comes down here. So I'm going to write back everything that is in the second, plus the second, times the differentiation of the first. And differentiating the first 3x squared is going to give me 6x. So all I'm doing here, so the difference between this one and this one, Chris, is that I'm rearranging. So I'm putting the 6x in front of. All right? And then this negative 6x squared times 4 times 3x squared is negative 72x to the 4th. So multiply 3 by 4 by 6 by negative 6, and should get negative 72.
Yeah, I get the 4.
Right. And then now, we're factorizing. So I'm subtract, as I said, note always factorize the lower of the two. So what I'm going to do is to see, what am I talking about? 5x, 5 minus 2x cubed to the 3rd, and then I have 5 minus 2x cubed to the 4th. All right? So 5 minus 2x cubed to the 3rd is lower than 5 minus 2x cubed to the 4th. So that's what I'm going to factor out. See here? 5 minus 2x cubed to the 3rd. But there are other things to be factored. Oh, you know that, sir? Because, see, and that's why I put it in the front. So at least you know you're consistent where to find it. So see, I have 6x right here, so, and I have a negative 72x to the 4th, negative 72x to the 4th, and 6x. What is common between the negative 72x to the 4th and the 6x? Well, sir, take out the low of the two. Very good. Because I have x to the first here, so, and x to the 4th. So I can take out the x because I have to take out the low of the 2. And then no, 6 is a factor of itself, and it is also a factor of 72. So I can take out all of 6. So the 6x will come out. So why never take out the negative? Because we have the negative sign right here. So, all right, it's a lower of the 2 that I'm taking out. And then no. So right, and the lower one is a positive. So what I'm saying to you is, I do not have anything else to take out. So now I'm going to close my parentheses. I'm going to close it. Sorry, I'm going to open my parentheses for what is left. Now, watch me. I'm doing this in 3 stages. What do I... Rockstone, you know, there's something wrong right there, so. Let me, I'll fix it.
Sir, remember saying I was looking at it and the 12x something should be in front?
No, man, it's negative, supposed to be a negative. What do I multiply by 6? What do I multiply by 6x to give me a negative 72x to the 4th? It has to be negative 12x to the 3rd power. So 6 times negative 12 is negative 72. and x times x to the third is x to the fourth. All right? So this is supposed to be 6x, rubbish, it's supposed to be negative 12x cubed. Because when you multiply negative 12x cubed by all of this, you should get negative 72x to the fourth times 5 minus 2x cubed to the cube. And then, what we multiply by 6x to give me this 6x is a 1. So I'm not seeing the 1 there, trust me, it is there. And then watch this now. This is a 5 minus 2x cube. What do I multiply by that in order to give me 5 minus 2x cubed to the fourth? Just a 5 minus 2x cubed to the first. Because remember, again, the laws of indices, one of the laws says, when you're multiplying and the bases are the same, you add the powers. So a to the m multiplied by a to the n is equal to a to the m plus n. So once I'm multiplying and the bases are the same, I add my powers. See, the bases are the same. 5 minus 2x cubed. 5 minus 2x cubed. So the bases are the same here. 5 minus 2x cubed to 5 minus 2x cubed. I'm going to add the powers. 3.
And the 1.
Right, to give out this 4 up here.
Okay.
And then now, this down here, so we can change. Copy. That down here, so we can change because I am now going to have negative 12x minus 2x is negative 14x. Plus 5. Negative 14x cubed plus 5. And that's my final answer. That's my final answer. What I'm going to do is...
Okay.
Please not give us any of these questions on the exam.
So that one of these are going to be on the exam, trust me.
You're not even that, you know.
Especially the mid-semester.
Especially plan for Monday, man. No one understand.
The truth is, even though your paper set already, me no know what will come now. Because the man them, the man them decide where they want to put on something. So even though X-Intercept would have, would have submitted their stuff, they don't know what it's gonna have. All right. Marie need to sort out her device. Somebody can help her, please. All right. I have some additional questions there that we can go through. I need to break though. And I have to, guys.
Okay, sir.
I'm gonna say break. I don't mean break.
Sir,
I don't say break to finish class, you know. Break to save. Break to move into
to start something else, sir.
Yeah, my screen not sharing, right?
No, not yet, sir.
No, not yet, sir.
All right, good.
I know you mentioned from the beginning, sir, that you're gonna have to touch on another topic, and I don't remember what you called it, but time is up.
Point.
So when you say you have to break, I understand that. So you have to break away from what we're doing to move on.
To move on to the other topic. Yeah. Real talk.
Sorry, next class, sir. Next class.
If Tucson, allow me alone, because tonight I do something. No, man, I have to talk to
sir, me just, sir, operation research, me just come out and I know them the long, you know.
Me know, Tucson, but guess what now? Don't worry about it, Tucson. I have to go to, I have to touch upon this. I mean, even if we just touch it and then we just finish it off, but we have to touch on it. But it's because I should have sent this here, D-I-F-F-E-R-E-N-T-I-A-T-I-O. You know, say, how that happen, you know? How that happen. I emailed myself the document to send off to you. Now that I type the name, and let's see. Let me see something here. When was the 24th? The 24th was Thursday. Yeah, at 7:59. At 7:59, I emailed the document to myself, and just didn't I emailed the document to myself and I did not send it off to you. All right, I'm just trying to send a document now, guys, before differentiation. I will come back to the document at some point in time. I want you guys to be able to go through it, you know. All right, let me just project. What is happening? Okay, share screen. Where am I? See where the function. All right, so I need to talk about that big boy. All right, so stationary point single variable function. Yes, Marie. You saying something?
No, sir.
Okay. So we're looking at stationary point single variable. Now, what I said to you some time ago was that f of y, f of x. When I differentiate f of x, I'm going to get d f dash of x. And when I find the second derivative, I'm going to get f double dash of x. But f of x is also equals to y, and f dash of x is the same thing as dy by dx. F dash of x is the same thing as dy by dx. And f double dash of x is the same thing as d squared y by dx squared. D squared y by dx squared. All right? I am not going to go through this summary that I have here. I'm going to just jump into the question. All right, sorry. So I sound distracted because I really want to make sure that I sent off the document that I just did. All right. I won't send this differentiation, this first principle, sorry. This one that I'm working with now, I won't send this tonight because I want this one that I just sent in the group. Please check because I just sent it in the group for you to finish working on that one. All right, so stationary point is really not difficult, but it's a question that involves differentiation. Normally, they give you a polynomial to differentiate. Normally, it's a polynomial that you're given to differentiate. And there are some steps that you have to follow. So for example, to determine the SP stationary point, the stationary point, we have to differentiate the function. Then we're going to set the differential equals to 0. Then we're going to substitute the critical values into the original function, because when you set it equals to 0 and solve, it gives you the critical value. Then to get the stationary point, which is the same thing as critical point, which is the same thing as turning point, all of them mean the same. We are going to be writing that from part 3. Then the question is going to ask us to classify the nature of the stationary point. We're going to use first differential, but we're going to differentiate it a second time, and then we're going to substitute the values that we got up here. So I'm speaking to it very quickly because I'm going to show you the example and then come back to this stuff. I'm going to substitute there. I will know whether or not I'm going to have a relative minimum or a relative maximum, or for that matter, I may have a saddle point. So these are terms that you need to know, right? And then we're going to look at the graphical method, but guess what? The graphical method is going to come soon. Then to determine the intercept, to evaluate the x-intercept, you can put y equals 0. To determine the y-intercept, to put x equals 0. This one is pretty easy to remember because whichever intercept you're trying to find is the opposite one that is going to be 0. Watch it. To evaluate the x-intercept, you can't put x equals 0. You have to put y equals 0. See? Them ask x-intercept, so you have to put y equals 0. Them say x-intercept, you have to put y equals 0. Them say y-intercept, you have to put x equals 0. Them can't answer to evaluate the y-intercept and you have to put y equals 0. That don't make it. So whichever intercept them asked to evaluate is the other variable you can put equals to 0. One more time. To evaluate the x-intercept, you have to put y equals 0. To evaluate the y-intercept, you have to put x equals 0. And then to determine the point of inflection, you can use the second derivative, set equals to 0, substitute the values from one above, and you can have your midpoint to give you the stuff. And of course, a sketch a graph. And then that comes to the first example. I'm more interested in doing the first example than anything else. When you do the first example, I can go through all of that with you again, and you're still not going to be able to use that information until you see how I do the question. Then I can go back to, the little narrative that I've written down. What it is that I've done up top that I just went through, guys, is to do a summary. So, I wanted you to always know what step to move on to next. So what I did was just to write a summary so that you can see step by step. So you know that you calculate the stationary points. There are 4 things for you to do. You're calculating this, there are 3 things to do. You're calculating that, there are 2 things to do. All right, so let's go. It says, given the function y equals x squared minus 6x plus 1. Given the function y equals x squared minus 6x plus 1. We're supposed to evaluate the critical point or the critical points for 3 marks. 2, the coordinates of the y-intercept for 1 mark. And then determine if the point or the points is a maximum or a minimum. And sketch the graph of y showing all the points. I'm not interested in sketching the...
Stick a whole pin, sir. No, you're not interested tonight, but suppose it comes by the mid-semester.
No. I'm not interested in it tonight. You never let me finish, man. I'm not interested to do the sketch of the graph tonight. But I am interested in doing parts 1, 2, and 3 tonight.
Yeah, man. Continue.
Yeah, man. All right, so let's go now. So you have y equals x squared minus 6x plus 1. The first thing that you must do when you get a question on stationary point, differentiate the function. Differentiate the function f of x. First thing to do. Let's go. Y equals, differentiate that function for me, please, and tell me what to get. Today, I would like the class to differentiate the function for me, please.
2x minus 6x.
I would like the class to differentiate it correctly for me, please. You see the error? You see the error?
6x.
Yeah, I know.
Yes, sir.
No, Yana. Me said, don't follow me. Me a madman. Don't follow me. Please.
Differentiate the function for me, please. Yana, don't make me come for you, Yana.
Say anything will come out of my life, but no more sweet, no sir.
Well, talk truth. Talk truth.
Yeah, man, with the past sleep mode, sir. Just let us do it in a car with the past sleep mode.
What is the differential of y equals x squared minus 6x plus 1?
Using, we have to use one of them, right?
Emilio, differentiate the function for me, please.
One moment, sir. All right. Okay.
So you have to lead in, you have to show how to differentiate it and then differentiate the next one after. So I say you do it.
Oh, really?
About a differentiation, so we should know if we differentiate.
Thank you, Marie, because this was done last week in class.
Hold on. You ask me a question. Give me a
We're not talking to you, I talk to Marie.
All right. So that would be 5x, sir.
I want to slap you silly. Your first answer was so close. I don't know where you get this one from. Go back to the first answer and fix it up for me.
Oh, all right.
Sir, is it 2x minus 6?
Thank you very much.
Oh, but so you go let me did wrong when we said the 2x. Is that right? No,
I don't have.
I just need them to take the extra.
I don't.
So that means that where Yana did I say was almost close to then.
Very good, but I don't want almost close. I want it to be close. You see me take it for either. I don't have to go too far, right? Just
Show me off everything. I'm on the right track here.
No, because you said 2x minus 6x.
No, I put back the x, but I realize that the x have a power of 1, so the x not there, so I stick.
And that's why I said, class, can you differentiate it correctly for me, please? No, man. So it's 2x now. Ricky, that was you, right, Papa?
Yeah, man. Ricky,
yes,
man.
Sir.
Yeah, man. Boy, Ricky, boy, very nice,
Ricky,
man.
the vampires.
I'm going to tell you. You see, at night time, Ricky, not ready for sleep yet, you know. All right, let's go. So it's going to be 2x minus 6, right? So dy by dx is equal to 2x minus 6. Look at what it is that I have done. Dy by dx is equal to 2x minus 6. You get a mark for doing that, for doing the differential correctly right there, right? So dy by dx, you have to differentiate the function. You have to differentiate the function. Now watch me. So the first step is to differentiate the function. Now you recognize that differentiating the function wasn't bad. 2x minus 6, you get a mark for doing that. Depending on the function, you may get 2 marks or 3 marks, all right? But this is an easy question. So we're differentiating the function, so we're going to get 2x minus 6. Watch me. 2x minus 6. The second thing says, set the differential equals to 0. That is, f dash of x equals 0, and solve for the unknown. Oh, so set it up like an equation, sir. Yeah. And this gives the critical value or the critical values. All right, so let me catch that. So again, let I'm going to let dy by dx equals 0. This thing is not responding, but I guess you can.
Christ, what is wrong?
Mr. Rasta, Maddy, I tell you.
X is equal to 3 because when I'm looking at the solution for 1 where you have 2 over 2, you divide both sides by 2, you end up with 2 into 6 goes 3 times, so the answer for that would be 3. X is equal to 3, sir.
Very good. Very good. Chris.
Yeah, smart.
But we don't understand. You can't get people like Emilio ammunition against you, man. You can't do that, man. All right. Let me stop share 1 minute, please. You can't get Christopher. You can't get Emilio ammunition against the teacher, man. That's all right, guys. I want to seal this seal.
What going on over there?
Let me stop share again.
Yeah. Stop and restart.
The document
about a bag of things.
Yeah, it is the most is going, but it's like it. Oh Lord. All right.
It's here.
No, man. I mean, Miss Martin and this one. I have this in many places.
Okay, sir.
I have learned my lesson, Papa. So. All right. So. All right. So. Let's go. It's the document not scrolling, but you're seeing it. So it says the critical point. So we have found what we did was to we differentiate it, and yes, Tashana, we differentiate it, and I'm going to set dy by dx equals to 0. So what I have done is to put the 2x minus 6 equals 0. So 2x minus 6 equals 0. Therefore, the 2x is going to be equal to 6. divide both sides by 2, x is going to be equal to 3. You notice that I have only one value of x. So I have just one critical value of x. In most of the other questions you do, you will get critical values. I doubt that they're going to give you a question like this that speaks of a critical value. I only gave you a critical value because I wanted to quickly point something out to you, right? So I don't think the exam is going to give you critical value. They will give you critical values. 9.5 out of 10 times is values they get and not value. All right, let's go. So when I get x equals 3, all I'm doing here now, I'm substituting. Don't even watch this over this side. All I'm doing here, I'm substituting now the value 3 into the original function. Or I can't scroll to show you what I'm talking about. But the third step is to substitute the value 3 into the original function. So let's go.
Sir, when you set 3 into the original function, you mean like it will be 3 to the second power minus 6 with open bracket 3 close bracket plus 1?
Very good.
Okay.
So my x equals 3 is only giving me the critical value of x. I now need to get the critical value of y in order to get my critical point. Because remember, my point is x and y coordinate. My point is an x and y coordinate. It's not just one x value. You remember when you write a point, you write x comma y. X comma y is a point. So you must have an x value, and you must have a y value. We just calculated the x value to be 3. We now need to work out the corresponding y value. And that's why we are substituting it into y equals x squared minus 6x plus 1. Because I know you guys very well, and I know you guys are not. Our visual learners, oh Lord, sweet Jesus, where did I put off? Because I know you guys are visual learners. And
So far what I come up with, when you have 3 squared, that is 9, but right. We get this a plus 1, you end up with -8 instead.
Right. So you can have 3 is 9. 9 minus 18 is -9, plus 1 is -8.
Is -8.
Right.
So that would be the y value, sir?
The y value is -8.
Y value is going to be -8. So the critical point is going to be 3, -8.
-8.
Okay.
3, -8. But what I was saying is that I know you guys are visual learners. And
so like your document now, move us go and talk, man. We are take, you notice we are catch it on little. Yeah, man.
Yeah, man, but no, man, you see, Miss smarter than this, you know. You see, when document fail.
Sir, I'm visual learner, cause.
No, I'm not gonna show it, but just same could have go and talk. Me could go and catch on little.
When one something fail, Papa, me smarter than technology.
Yeah, me know, but a 9:30, so you have to watch your time too as well.
Yeah, I know that. I'm very aware of that. So the point I'm trying to make is, when it thinks it will get the better of me have the upper hand.
Yeah.
So, in one document now working on this.
Are your phone you share it from now?
No, my tablet, my writing tablet, so I'm going to write instead.
How come I wonder it looks so small now?
Yeah, so I prefer to type, because at least you have the information there that you can, see quickly. But let me just get this question. What was the question was y equals x squared minus 6x.
Yes, sir.
X squared minus 6x. For the last bit again, sir? X squared minus 6x plus 1. X squared.
All right.
Yeah. We don't want your poof. X squared minus 6x X squared minus 6x plus 1. All right, plus 1. So what I'm saying to you, the first step number 1 is to find the differential. So dy by dx is going to be equals to 2x minus 6. So dy by dx is going to be equals to 2x minus 6. That's the first step. Now, the next step, I'm going to let 2x minus 6 equals 0. Right? I'm trying to find a stationary point. I'm trying to find a critical point. Same thing as stationary point and turning point, eh? But I'm trying to find a critical point. So what I'm going to do now is to say, let the derivative be equal to 0. Find the derivative. Then let the derivative be equal to 0. Then I'm going to say 2x is equal to 6. Divide both sides by 2. X equals 3. All right? Then I'm going to put x equals 3 into y. So anywhere in y I see x, I put 3. So y is going to be equals to 3 squares minus 6 times 3 plus 1. 3 squares is 9. 6 3s are 18 minus 1 plus 1, which is going to be equals to negative 8. So therefore, CRITICAL, the critical point is just 1 point, is going to be 3, comma, negative 8. That's what the critical point is. 3, comma, negative 8. Right? So that's what my critical point is. Now, what is the critical point? So what do you mean by critical point?
The y value is 3 and the x value is negative 8, sir.
Very good. No, the
x value is 3 and the y value is negative 8. Sorry, my head.
Right, very good. So the x value is 3 and the y value is negative 8. That particular point, 3, negative 8, is saying to you, me, and the whole world, anywhere at all in the world you go, I give them that. I told them that to do in a stationary point question.
On the graph.
On the graph, right. They will know that that's
where you have the point. X. On the x-axis, the 3 would be there, and on the y-axis, it would be down to negative 8. That negative point right 8. There on the graph, that full stop.
That is going to be there, and it's going to show you that that graph sits, the graph sits on that point. That point, 3, negative 8, is a specific point on the graph, an important point. Yeah. All right, watch me now. So that's part 1. Remember, I'm only interested tonight in doing 1, 2, and 3. So that's part 1 of the question, to find the critical point. We just did that. Then it says now to find the coordinate of the y-intercept. Okay, sir, to find the y-intercept, which one is equal to 0?
X.
Very good. So just remember that there's an opposite one that is going to be equal to 0. So part 2 now. Part 2 says we're going to find the opposite one. So we're going to let x equals 0. So y is going to be equals to 0 squared minus 6 times 0 plus 1. So y equal 1. So the coordinate, C-O-O-R-D-I-N-A-T-E, the coordinate is going to be 0, 1. That's why that is only 1 mark. Very easy, 0, 1. And then the last part of the question now says, determine if the critical point is a maximum or is a minimum. So what I was trying
to... The fact that the critical point where y is on the axis is negative 8.
Yeah, minimum.
Thank you.
Well,
Which one of them you're doing, sir? Is it the coordinate for number 2 or for the first one, sir? Because so far we have the critical point and then you have the coordinate, which is what x is equal to 0 and y is equal to 1.
Okay. No, it's just that I hear a suggestion. You want someone came out and said.
But I'm asking, sir. No, I'm asking because I'm seeing where you have a critical point up there. We discussed that already. And we moved on to 2. And you said the third question is asking whether there's a maximum or minimum point. And I'm saying which one does this apply to? Does this apply to the critical point or to the coordinate?
It applies to the. It's one question we're doing, you know. Is one question we're doing. So it applies to the question.
Where the confusion is, sir.
No, there's no confusion. It applies to the y equals x squared. It applies. Okay. It says determine if the critical point is a minimum or a maximum. No, which one is the critical point?
The critical point is 3, negative 8.
Right, 3, negative 8. And then what I'm hearing to someone say, both of you came out with, and they can't look at it like that to say it's a minimum or a maximum or a saddle point. You got to work it out.
No, because we can see it because negative 8 go down. So you dip go down.
Sir.
So,
all right, listen.
Sir. All right, we're putting H. I'm remembering vaguely about the H thing.
No, man, no. He said that H something over there, so I was just trying to bring across a point, but that point not going to show tonight because the document is not scrolling. So hold on to that piece until afterwards. There's just a point I was trying to bring across there, but it's the document not scrolling. I just tried it a while ago. So let's do it on the screen. Okay. I'm gonna find d squared y by dx squared. That's what I'm gonna find. And I'm gonna see if when I find that, if it works. Now, in order to do d squared y by dx squared, I have to use this. Sir, why do you have to use that? Because that was the first derivative. Now I need to differentiate the function one more time in order to find the second derivative. I said this to you last class. That I can find the first derivative, I can find the second derivative, I can find the third derivative, so forth and so on. I can go as many times as they ask me to do. All right? So I'm finding the second derivative. Now, when I differentiate 2x minus 6, one more time, what do I get as my answer?
Repeat the question, please.
I'm finding the second derivative. Mm-hmm. It means that I'm going to differentiate the first one more time. So therefore, when I differentiate 2x minus 6, what do I get?
2 minus 6 gives you negative 4.
You see? I forgot to tell you what I want to tell you, Emilio, off here. Yeah, I forgot to tell you. Yeah.
You don't say me stop that. You're going to make it do your class. Don't stop.
No, man. No. It's just that we want to tell you something, but we can't tell you because I'm being recorded. So, but
no, you can't WhatsApp me after the class.
Jesus still a watcher, yeah?
Continue. Yeah, not get between me and him, because when it comes to argument, dangerous.
Tell me now, differentiate 2x minus 6. Ricky, come, help them out. Differentiate 2x minus 6 so me until I get.
That will be 2, sir.
No, Ricky, pop. The man sharp today. Ricky, where you for lunch today?
I'm listening, sir. I'm listening. I was practicing.
Ricky, no, man. I forgot
because x would be to the first power, and when you minus the 1 from the 1, you end up with just 2. When the constant is there, that is a 6. We know that the derivative of constant is a derivative. The constant itself, yeah. So it would be 0. So right. Yeah. So the answer would be 2. That is correct.
Very good. Now, somebody who work at town, I forgot what was saying to me, go by Ricky and Tigers, Very good, Ricky. No, man, Beijing. Nice. So the second derivative is going to be equals to 2. Very good. The second derivative is equals to 2. Very, 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 very nice. So now we are determining if that is, if the critical point is a maximum or a minimum. No, we hear Tashana and we hear Tucson say, sir, a minimum, you know, okay, go down this and it turned up in that and that and I say, all right, make we check with self. Make we check with self.
A maximum, sir, kind of no.
No, what do you need to make up in the mind, you know? Maximum, minimum, what do I say?
I got a maximum, sir.
Minimum, me the said we man. Minimum said we.
All right.
So if it do have any minus beside it, sir, then it would be a maximum. But if minus beside it, it's gonna be minimum, sir.
Okay. Say it one more time, Marie.
I was saying, sir, if it don't have any minus beside it, it's gonna be a.
Sir, what?
Hold on. Say it, Marie. Say it again, Marie.
All right, sir, I was saying if it don't have any minus beside it, it's gonna be a maximum. But if it have a minus, if it's -2, then it's gonna be minimum. The 2 years, sir. So I was saying if it's not, if it don't have any if it's the 2 you're going to work with, because you work it down, you derive it again, answer operator. So if
so like you didn't get it right the first time, Marie.
No, because I say if
it's wrong, man.
Work with it,
Marie, you know, one of the things that I pride myself in doing while I'm teaching, I like giving students an opportunity to speak, you know, exercising a democratic right. And then I use your to put it into the right section. No, I'm going to ask you to repeat what it is that you just said. I heard what you're saying, but I'm going to ask you to repeat so that you can see if you can pick up the error that you've made. And the rest of you, I want don't speak. Think and just listen to what she's saying and see if you can pick up where it is that she went wrong, because she went wrong somewhere. And I want to help her in doing something. So Marie, I'm putting you on the spot again. Say what it is that you said. Yeah, say what you want to say now.
What I want to say, sir.
Yeah, so talk about the two. Talk about the 2 in yellow. The 2 in yellow says what? What does the 2 in yellow say?
That's just a regular 2, not a negative 2.
So it's a positive 2 then?
Yes, seem like it's a positive 2.
No, so seem like. It's a positive 2.
Yes, sir, it's a positive 2 because I don't see any negatives.
Right. So I agree with you right there. So yeah, tell me the story now.
So I was saying, sir, I was just trying to remember something that I got in FCM 2. I don't know if I'm saying the right thing, but I was looking at it and said there is no negative beside it, beside the 2, then that would be a positive, that would be a maximum. But if it was a -2, then it would be minimum, sir. So
all right. So you're sticking to your story like Tucson said. All right, Tucson, your turn, Papa. What she said is correct. Tucson, let's see.
There, sir. No, give me a minute.
Yeah, go on, watch this for the.
Can I speak now, sir?
Yeah. Go ahead, hon.
All right, I'm going back to the original function. Y equals x squared minus 6x plus 1. According to the rule, if the first section where you have 1x right there in front is positive in the expression, then it's a minimum function. It's called a parabole, which has its lowest point referred to as a minimum. So from you see positive right there where you say the 1x in front, y equals 1x squared, because the 1 is there even though we don't see it. It's supposed to be a minimum function, sir.
Okay, all right, fair enough. I hear you. All right, cool. I won't tell you to right or wrong yet, you know, because I don't even tell Mary to right or wrong yet. Very nice. I mean, I like the letter. Where am I going?
Wrong.
No, where am I going? I just said letter a while ago. My goodness, I think it's bedtime for me, you know. Letter. I like the level. That's the word. The level of reasoning there. So Marie, I like your reasoning, you know. Right? There's something that I need to fix with it, you know, but I like your reasoning. Just on place, you know. Time expired. Come to son. Tell me what you say.
Hold on. Me know she said the rule say anytime it's a negative, it's a maximum, and it's a positive, it's a minimum. And that the rule say no. And but
hold on,
we can
hold on,
tell us the K
hold on,
body
Tusan.
can tell
No,
you know.
no,
If we do the
no,
K
hold on.
body,
No,
we can
Tusan, hold on. Marie, you hear what Tusan say a while ago?
Yes, sir. Him say it's opposite of what I
Ah, he said the opposite to what you said, right? So I want you now to listen to what Tashana and Tusan says, the T's, and then now we're going to put it to the T. Blow, Sir Connie tonight, man. So let us see what happens right here. So Tashana says, once the coefficient of x squared, she never said it like this, but this is what she means. If the coefficient of x squared is positive, it means that the graph is a minimum. And if the coefficient of x squared is negative, the graph is a maximum.
Then it would be a maximum, sir, just like Toussaint said.
And what Toussaint said is that if it is a positive, sir, it's a minimum. And if it is a negative, sir, it is a maximum. All right. Now, watch me. And I'm rapping incidentally. Just trust me. My eyes now feel. I'm going to put it in red. Danger.
The fact that it's a quadratic function, you know, sir.
Huh?
The fact that it's a quadratic function, it means the rules apply, sir.
It does. But I mean, in this case, you'll have to show them why it is a minimum or a maximum. So you can know that it's a maximum or a minimum, you know, from the equation. But you will now have to show them that it is indeed a maximum or it is a minimum. So you can't just tell them no, say, the rule says because of that. You know, oh, sir told you the rules, or whoever told you the rules, that the coefficient of x squared is positive, so therefore it's a minimum, and it's negative, it's a maximum, is because of this topic that we're studying. So when we study the topic and we do all these questions and we get the answers, we say, oh, yeah, man. I say it go. So you can't use the theorem without first proving it, so to speak. So that's why we have to go back and show them this. All right, watch me now. You see that graph? That graph looks like a
upside down V.
No, not call it so. Call it an N.
A parabole.
It's a parabola. Both of them are parabolas. Right. So they are parabolas.
One is maximum.
Right? One is a maximum and one is a minimum. Now, no, I'm trying to get you to remember which is which. Now, this one here, this one.
Maximum beside the one there.
That one shapes like a what letter of the alphabet?
Yeah.
Huh? N. And how do you spell negative?
N.
All right. So you see, anytime I say the hen graph, it means that it is negative.
Oh.
And it means that it is a maximum graph, because the maximum graphs are the N-shaping graphs. And the minimum graph is going to be the positive U-shaped ones. So this is a minimum graph because it shapes like a U, and that's a maximum graph, it shapes like an N. Now, hear this story. Hear this story, and I want you to be able to repeat this story. You see, when I go to school, I got so confused, and I'm telling you this because I want you to recognize how real your teacher is. I got confused knowing which is maximum or which is minimum, and sometimes teachers say, Sean, what shape is this? Minimum. Okay, very good. And I said, no, I understand it. Sean, what shape is this? Minimum, sir. No, it's a maximum. I'm saying, oh, you get maximum. And for the life of me, whenever I got this question, I used to just guess, and I said, no, I need to fully understand. And I look at it and I said, oh, but hold on, no. I go study one of them, and the other one will be the opposite. Because when I study the two of them, never get confused. So I go study one, make it pat, and then when we catch the other piece, I just say opposite. Watch me. Look at where you see my spotlight. My spotlight there is in the shape of an N. N means negative, and the negative graphs are maximum graphs. N means negative, and the negative graphs are maximum graphs. Therefore, The U graph, because we know says N is either N or U, up or down. The U graph has to therefore be the minimum graph, because if you have maximum or minimum, that means if it's not one, it's the other. If it is not up, it is down. So see, would I want to shape down maximum for negative, negative for negative, and then the minimum graph is going to turn up. So the minimum graph is positive, the maximum graph is negative. No. So Tashana did it from the end to the start, but Tucson did it from the start to the end. So one goes from end to start, and one goes from start to end. So this is what it is saying. And Marie got this portion correct. Marie says, but sir, the +2 year, sir, the +2 year, have something to do with it, you know. And she's correct. That second differential.
Sir.
Huh?
All right. This negative, this negative one that is, you say, is the maximum. Where the let them call up here so again.
Turning point, the critical point.
The turning point, sir. It cannot go higher than right here. That is it, right, sir?
So the critical point here, it has to be right here, so the 3, -8. It has to be with the 3, -8.
Right, and it can't go no higher than there. So.
Can't go no higher than that. That is going to be the maximum point of the graph.
The critical point is also called a turning point. Sir?
And it's also called the stationary point.
The critical point is also the turning point is also the stationary point, sir.
Also the critical point, yes, has 3 names.
Okay,
so critical point, stationary point, turning point. All right. So that's what that one is. And guess what? That's what I want to do for the video tonight. I just want to introduce it, you know. So let me just go through quickly what we did.
You know, we have to go behind and be a police like on the road, you know.
Hello, you know, yeah, yeah.
I'm having papers, sir. I'm having papers, sir.
Work with this, sir.
Oh, you know, yeah, essential work, come on. Yeah, a bodyguard, a good man. So what is happening is
sir, they can't do.
Y equals x squared minus 6x plus 1 is a given question. Just remember to find a critical point, I have to differentiate. Look at 1. We differentiate, we got 2x minus 6. Right? But the question don't finish yet. We don't finish the first part of the question yet. What we don't need to do is to put the dy by dx equals 0. When we put the dy by dx equals 0, now we're going to solve for the value or values of x. We did that and we got 3. Now we have to substitute the 3 now into the original function in order to get the y. We substitute in there, we got our y to be -8. So 3, -8 is our critical value. 3, -8 is our critical value. All right, and then the question says to determine the coordinate of the y-intercept. Yes. To find the y-intercept, you're going to put x equals 0. To find the x-intercept, we put y equals 0. All right, this is the opposite one, we put equals to 0. And then the last part of this question that we did says that to determine if the critical point is a minimum or a maximum, you have to find the second derivative. If when you find the second derivative and substitute the value in there, and it's positive, it's a minimum. If negative, it's a maximum. Voila, that's it. Thanks for coming out. You have the document. I'm not going to send this one. Matter of fact, I can't open to send it in the event. I'm not going to send this one just yet. On Thursday, I'm going to go back to the document that I sent you just not too long from now. Just to look at 1 or 2 more of the questions, and then I'm going to come back to this document. Have a wonderful day.
Thank you, sir. Same to
Yes,
you.
sir.
Bless you.
Can somebody screenshot this and send it to the group, please?
Tasha and I will. I did it.
All right, thank you.
As for the you them of course. Adopt it time. The adopted time. Anywhere we not call. Don't when I'm going to go with name, I no right. When I say nothing, off your mind. Okay, military style. Sure. The index of variable. All right, I got my this, I got my that. All right, what am I leaving though?